Okay, so we're going to do some more Snell's Law practice. So here I have drawn for you an interface that is separating two media. The first medium is diamond and the second medium is zircon. So the first thing that we notice is our incident ray of light is striking the interface at a 15-degree angle relative to the normal. Remember, the normal is that perpendicular imaginary line that runs at a 90-degree angle to the interface. And remember, when we shine light sitting directly on the normal or 0 degrees from the normal, that light will not bend. In other words, it won't refract. But once we move that light source to an oblique angle relative to the normal, that light is going to bend when it is transmitted across this interface. So we now want to find, given this angle of incidence, what is the angle of refraction? In other words, when the light passes from diamond into zircon, what is the new angle relative to the normal? Okay, so we're going to start out by using Snell's law. So given the indices of refraction of these two media, diamond we know is n equals 2.42. That's in your reference table. And zircon has an index of refraction of 1.92. Okay, we'll call this medium 1 and zircon will be medium 2. Okay, so now I'm just going to set up Snell's law. So we have n1 sine theta 1 equals n2 sine theta 2. Plug everything in. So for our first medium, just make sure that you're matching up the proper index of refraction with its corresponding angle. Sorry, we know theta 1. What am I doing? Theta 1 is 15 degrees. Okay, and that's going to be equal to 1.92 sine theta 2. So theta 2 is currently unknown. Just make sure that your calculator is in degree mode. So the first thing I would do is sine of 15 times 2.42, divide that value by 1.92, and then you take the inverse sine of that value, which is going to give you that theta 2 is equal to 19.4. That's not correct. Hold on one second. It should just be 19. Let me double check that. Yeah, 19 degrees. Okay, so just check that in your calculator to make sure you're able to plug that in. Okay, so now I wanted to give you a more complex one. So sometimes light is not just passing from one medium into another. Sometimes it's going to travel through several different media. Okay, so what we have here is it first travels through glass and reaches this interface between air and flint glass. Then from the flint glass, it's going to travel into diamond, then it's going to travel into corn oil, a vacuum, and then lucite. Okay, so this is highly improbable, but I just want to show you how it would be done. So the first thing we do is we're going to isolate the first two media, and we're going to use Snell's law. So this is going to be medium 1, which we know has an index of refraction of 1, because air is similar to a vacuum. Flint glass has an index of refraction, I think it's 1.66, but I just want to look and be certain about that. Flint glass, 1.66. Okay, so N1 is 1 for air, and 2 is 1.66. Okay, so given this information, we're going to isolate the first interface, and we're going to apply Snell's law. So I'm going to do N1 sine theta 1 equals N2 sine theta 2. Plug everything in, 1.00 times sine of 30 degrees. That's the angle of incidence that I gave you. And that's equal to 1.66 times sine of theta 2. And I already calculated it, and I got that theta 2 should be equal to 17.5 degrees. So now that I have that value, I'm going to draw that in. But not only am I going to draw that in, 17.5 degrees relative to the normal, I'm going to draw it all the way down to the next interface. In other words, just like this. Okay, so if this angle right here that I've designated relative to the normal is 17.5 degrees, which we just calculated, then if I draw in my new normal where the light is striking this next interface, here's my new normal. Okay, so here's the normal, right? Then if this angle right here is 17.5 degrees, this angle right here must also be 17.5 degrees, because those two angles, let me circle it in a different color. Those two angles are alternate interior angles. Okay, so you actually now know the angle of incidence for this next interface. So now we're going to move on to our next interface. Well, N1 of the flint glass is still 1.66. N2 of the diamond is 2.42. Now, once again, we're going to apply Snell's law to find the new angle of refraction relative to the normal. Okay, so theta 1 is now 17.5 degrees, alternate interior angles, just making that note so you remember why. And now you continue on to solve using Snell's law. So we'll do it again. N1 sine theta 1 equals N2 sine theta 2. Okay, plug everything in. N1 is now 1.66 times sine of 17.5 degrees equals 2.42 sine theta 2. And I believe when I solved for it, I got that theta 2 should be 11.9. So theta 2 is 11.9 degrees. So now I'm going to draw that angle of refraction in all the way to the next interface. So sitting even closer to the normal. Okay, so here's my next angle. So now if I draw in my new normal right here, this new angle will be equal to this angle of refraction. Okay, so now theta 1 is 11.9 degrees, and 1 is 2.42 because we're still in diamond, but now that's our first medium because now we're dealing with this interface. And N2 is whatever the index of refraction is for corn oil, which if I just check my sheet, I will know. Oh, here we go. Okay. Corn oil, 1.47. And again, this is in the reference table. So now you can apply Snell's law, and I want you to now find for me the index of refraction here, index of refraction here, and the index of refraction here. So you're going to do those last three on your own. Okay, so that's going to be what you submit to me this time. Thanks, guys.